Greetings to all the viewers. This is a session going to cover with the textbook of natural products nurturing the livelihood. Natural products are very potential and pivotal in the day-to-day life of each and every organism. They are very essential ingredients which are required for the healthy survival of all the living organisms. That is the reason why these natural products taken into the consideration. Series of sessions are conducted based on these natural products, their origin, introduction, their significant role in the medication, and even classification of these compounds, applications in general. And we entered into the chapter 1 where it comprises of alkaloids. Alkaloids are naturally occurring compounds once again, and they extracted from the plants in general, and nitrogen is the essential element. In that field, the quinine is the example taken over there, and that part is also finished up. Right, all these topics whichever covered earlier available at the channel called World of Competitive Chemistry. Let me repeat, World of Competitive Chemistry. Now we entered into another example of the alkaloid called morphine. Let me introduce the compound called morphine over there. So morphine is the compound. Let me see the introduction regarding this one. Morphine is the naturally occurring compound where the skeleton is made up of benzyl isoquinoline. Isoquinoline is the core in the case of morphine. So benzyl isoquinoline is the kind of nucleus present in this alkaloid obtained from the latex of the opium poppy. So this is the one morphine extracted from the opium poppy. So that plant significant name will be Papaver somniferum. It is one of the most important narcotic analgesic. Narcotic analgesic is nothing but having the addiction property if continuously consumed, and is widely used in medicine for the relief of severe pains. That's the reason why we can say it is the analgesic agent. Analgesic is the terminology which used to relieve the pain. So that is the reason why in the medicinal field it plays a crucial role. Morphine extracted from the opium poppy called Papaver somniferum is the plant, right? IUPAC name resided for this morphine will be 4R, 4AR, 7A, 7AR, 12BS. 3-methyl 2, 3, 4, 4A, 7, 7A, hexahydro 1H. 412 methano, benzofurano, 3, 2E, isoquinoline 7, 9 diol. These many components resided within this morphine nucleus, and this is the systematic IUPAC nomenclature. IUPAC denoted for International Union for Pure and Applied Chemistry, right? Morphine and codeine are the major and widely studied isoquinone alkaloids. Both are analogous compounds only. Both are equipped with the isoquinoline at their core. They are derived from the tyrosine and phenylalanine. The starting material for the biosynthesis of this morphine will be tyrosine, or else phenylalanine can be taken as the starting material. Morphine is the principal active component of the opium and typically constitute 8 to 15 percentage of the opium. So from this opium poppy only we are supposed to extract this morphine compound. That's the reason why here the constitute of 8 to 15% opium will be there. Chemically, it contains phenanthrene skeleton. So phenanthrene is nothing but it is a kind of a puckered ring system with three fused ring systems. You can observe one is benzene, one is saturated, and either is unsaturated, which are located not in the straight line, rather it is the kind of a puckered one. This is said to be what phenanthrene skeletal ring structure. Several functional groups are allocated for this one. If you observe, there is a phenolic benzene with a hydroxyl called phenoxyl. Phenolic hydroxyl group is located, and alcoholic hydroxyl. This is the hydroxyl unsaturated ring, so that here alcoholic hydroxyl. And even here you can notice this nitrogen, which is tertiary in nature. Around the nitrogen, 3 alkyl groups are located. That's the reason why it is the tertiary amine compound. Ether linkage is between the two ring systems. This is called the ether linkage. You can simply say saturated furan ring is also located over there. This is about the entire chemical skeletal structure for this morphine molecule, where you can locate the phenolic hydroxyl and simple hydroxyl and ether linkage. It is the tertiary amine. The phenanthrene skeletal nucleus is indicated for this morphine molecule. The molecular formula of the morphine is indicated as C17H19 nitrogen and O3, right? 17 carbon atoms, 19 hydrogen atoms, 1 nitrogen, and 3 oxygens are located for this morphine compound. It occurs as a colorless crystalline needles, right? So, in general, it is extracted in the pure form in the form of crystalline needles and forms the salts with acids. Being it is the kind of nitrogen containing compound, basic in nature, that's the reason why obviously go with the reaction with acids and they're able to generate salts by the process called neutralization. Morphine hydrochloride and morphine sulfate formation is possible if you treat with hydrochloric acid or else sulfuric acid respectively, which are used in medicine. So generally they're available in the salt form, in the stable form. That's the reason why morphine hydrochloride and morphine sulfate commercially available forms. These are used in the medication. Morphine was first isolated in the year 1806 by the German pharmacist Friedrich Sorterner, marking the first alkaloid ever isolated from the plant, right? So the isolation of this morphine historically started in the year 1806. The scientist credit given to German physicist Friedrich Sorterner is the scientist who gone through this isolation process of this morphine. This is the way from the plant the morphine alkaloid got first extracted, and you can observe the alkaloid morphine origin from which you are able to extract that one. This is called opium poppy of Papaver somniferum is the plant from which you are able to extract this morphine in the economic content. And what significance you can observe for this morphine, why we need to study about this one. So what significance is accorded for this morphine chemical compound? Morphine has a great pharmacological and medicinal importance. So it is mostly applicable in the field of pharmacology. It is one of the most powerful natural analgesic. Relieve the pain is called analgesic property. Whenever severe pains are there, if a person with an injury, person with the post-surgery pains suffering with, at that condition, morphine is most suitable for the consumption. It played a major role in the development of modern pain management and anesthesiology. Morphine having the tendency to pass the activity of neurological system, central nervous system is some extent. Sometime you can make it unconscious, so that anesthesia, local anesthesia is possible by means of this morphine. Whenever any person is subjected to surgery or else any kind of what any kind of surgeries we are subjecting them, so anesthesia is very important, right? Any medical treatment is required, anesthesia is important, right? At that condition, morphine to be sufficiently injected, so that surgery pain will not be experienced by that person. So this is the way pain management is efficiently managed by this morphine compound. Morphine served as a starting point for the synthesis of many opium drugs. So, being it is a kind of itself, it is a drug for the relief of the pain and even anesthesia agent. It also serves like a starting material to synthesize many modified drugs further. Some other advanced drugs will be synthesized starting with this morphine as well. It has been crucial in studying opioid receptors and neurotransmission in the nervous system, right? So, in the nervous system, if you want to study about the functioning of nervous system, efficacy of nervous system, stimulation of the nervous system, a study about that kind of neurological system, morphine plays a vital role over there. It's a prototype compound for the opioid analgesics. In order to synthesize new drugs containing, starting from this opium analog, so it works like a prototype. By taking this as a standard one, some other new compounds will be developed. This is the way it will be the prototype, it will be the standard for the synthesis of new variety of drugs in this segment, right? So this is the way you can observe the analgesic agent. It will be which used to relieve the pain in general. Various reasons in the obstetrics are possible during the pregnancy. Headaches, back and the pelvic pain if present at that condition. Also, you can relieve pain of uterine contraction and the cervical stretching, vaginal. All these kind of pains will be effectively relieved by means of this morphine. Right, extraction and isolation. Being it is a natural product, we need to extract this morphine from the opium poppy, right? The extraction process is manifested over here. The process begins by extracting opium using alkaline alcoholic solution, right? Opium was finely grounded and now it is treated with alkaline alcoholic solution that is mixed up. And this step is essential. It dissolves the morphine. In order to dissolve the morphine here, the solvent suitable is alkaline alcoholic solution. Alkaline alcoholic means a basic alcoholic solution to be taken, and the opium poppy dissolved in that, so that morphine will extracted into that solution. Then opium alkaloid, making them easier to separate from the solid components. Whichever solids are present in this opium poppy that remains as a solid only, morphine will be extracted into the solution form. Right, filter. Whenever you're filtering, solid remains on the filter paper, and whichever liquid extract of this morphine will be there, that will be separated. Whenever you're evaporating that one, being alcohol is highly what easy to evaporate. That's the reason why that morphine remains in the petri dish, and that solvent will be immediately evaporated, leaving behind the residue that contains the dissolved morphine within. And whatever solvent is there, immediately that is evaporated. The residue is subsequently extracted by alkaline aqueous solution pH 11. Basic solution to be added, you may go with sodium carbonate, sodium bicarbonate. Such basic solutions within water will be added in order to maintain the pH of 11. Basic medium to be generated over there. The alkaline aqueous solution filtered once again. We need to filter one more time to eliminate remaining solid. If any solid remains with that morphine, to be discarded by means of one more filtration step. And to prevent the formation of emulsion during the extraction process, solution is agitated with sufficient salt. Salt to be mixed up in order to avoid the emulsification. Emulsification giving rise to a kind of solution into the kind of in between. That may not be a solid perfectly, that may not be a solution perfectly. In between state, that is emulsion will be generated, so that it is not possible to extract in a sufficient quantity, economic quantity. That is the reason why salt to be mixed with that reaction mixture in order to avoid the emulsification of that morphine. The step is important to avoid the emulsification, and which will make the complication in the extraction and purification process. Contaminants will may bind up with that morphine compound, so that it's difficult to go further. The alkaline aqueous solution is extracted with organic solvents. Now, after mixing up with the salt, now the suitable solvents to be added over there. The solvent either toluene or benzene. Toluene, benzene when mixed. Morphine being it is organic compound, obviously it will go into this solvent phase. These solvent help to separate morphine from others. If any inorganic substance, inorganic components left behind, so they will not react with toluene or benzene. Rather, morphine sufficiently extracted into these solvents, so that separation becomes very easy by this process. Now, pH of the alkaline aqua filtrate is adjusted to 8.5. At this time, we already have pH of 11, right? So, certain extent, we need to lower that pH by adding the suitable reagents, so that pH will be reduced to 8.5. So certain basicity will be lowered now. Uh, Adjustment causes morphine to precipitate as a solution, allowing collected and purified. At this pH 8.5, morphine, which extracted into this toluene or benzene, will be crystallized. Now, pure form of this morphine will be extracted into that petri dish. This is the way a simple extraction process is provided. First of all, we have to collect the opium poppy that should be finely crushed, and alkaline solution to be added with that one. Alkaline solution, if added, that morphine extracted solid left behind, you have to filter that one. One more filtration is required. Later, we need to add certain extent of basic solution, pH 11, to be maintained. Then pH at the pH 11, what happened? This remains in the basic form only, and later a slight amount, a pinch of salt to be added in order to avoid the emulsification. Emulsion formation may not be possible, and after adding that a pinch of salt, a toluene benzene solvent, either toluene or benzene, to be added in order to extract the morphine into that organic phase, and whatever inorganic or crude products or solid products left behind, they will be discarded in the form of solids, and that morphine extracted into either benzene or toluene. Now you need to slightly lower the pH to 8.5 by the addition of acidic solution. Now, but it will sufficiently precipitated. Morphine will be precipitated at this either pH of 8.5 or 9.5. So that is existing in pure crystalline needle form now. Being morphine is a crystalline needle form, so you are extracting in a pure form. So that entirely provided in the chart form as well. Raw opium to be collected first, refluxing with the alcoholic solution as we discussed, and further filtration required, and that methanol to be evaporated. Then total alkaloid will be taken into the petri dish. Now, basic solution to maintain the pH of 11. Alkaline solution filtrate will be taken out and mixed with the toluene. Toluene able to extract that toluene fraction will be there, that able to extract that morphine into that compound. Further pH to be lowered by the addition of acidic solution. Morphine will be precipitated, and by filtering that one, any other components present, that byproducts will be removed out, and the crystalline solid of morphine will be extracted in a purified form. This is the way the entire extraction process got carried. Now let me go with the next segment called biosynthesis. Biosynthesis means for, as already we aware, morphine is the natural product. As default, it is present in that opium poppy. Then let me know how this morphine synthesized within that plant. Okay, that biosynthetic pathway we are going to discuss about. Morphine biosynthesis is papaver somniferum. It will be started with papaver somniferum. This is the origin for this morphine biosynthetic pathway. So in this papaver somniferum, here the amino acid required as the starting material will be tyrosine. Tyrosine taken as a starting material. So there are certain steps involved in the biochemical transformation of this morphine. Tyrosine initially turned into a dopamine. Dopamine is the essential neurotransmitter in the living organisms, very important for the stimulation of the nervous system. All the kind of neurological functioning is harmonically maintained by this dopamine only. So this is very important actually. Tyrosine now turned into a dopamine. That tyrosine may also converted into 4-hydroxyphenylacetaldehyde as well. This is a biochemical transformation. Whenever these molecules are supposed to be treated with a certain enzymes within living cells, so there is a chemical transformation is possible. Hydroxyphenylacetaldehyde will be generated. Here, one dopamine compound generated, one hydroxyphenylacetaldehyde formed. Both are supposed to be mixed up. They are added in certain ratio, certain manner. There is a formation of S norcochlorine. S-norcochlorine is a new lead compound or intermediate compound originated within the biosynthetic pathway. So this norcochlorine further turned into a kind of S-reticulin. S-reticulin formed. This is S-reticulin is the intermediate, which is the key intermediate in this biosynthetic pathway. The reticulin is further turned into salutaridine. Salutaridine is another chemical entity. Salutaridine further converted into thebaine, thebaine to codeine, codeine to morphine. All these are the analogs of that morphine only. All these are having same kind of activity only, but morphine finds the potential applications in the medicinal field. Thebaine, codeine, all these are also very important in that medicinal field, but the potential applications are recorded for that morphine only. That's the reason why final morphine is formed starting from this tyrosine. So many chemical transformations you can notice in between, right? In that, important to remember how many intermediates are crucial in the biosynthetic pathway. One is to be reticulin. Reticulin is one of the intermediate you already saw. As reticulin is formed from norcochlorine, right? And thebaine. Here is the thebaine you can observe, and the codeine. Codeine is also in either biotransformative intermediate you can notice. These three are crucial in the biosynthetic pathway of morphine synthesis process. This can be mentioned in the schematic form as well. Let me go with the step by step explanation for this biosynthesis of morphine in the papaver somnifer. We are uh, if we are starting with tyrosine, it will become very large biosynthetic pathway. In order to minimize, we are going with this reticulin. We are starting with this reticulin. Let me go with that reticulin as a starting material. Here is the reticulin taken. So reticulin oxygenase is an enzyme. Being it is a biosynthetic pathway, no external reagent is added. Rather, plant able to secrete its own enzymes in order to transform these chemical components. So that reticulin oxygenase is the enzyme secreted, which transform this reticulin. Reticulin is a kind of molecule. You can notice isoquinoline nucleus is there, and here is about benzene nucleus. Both are connected with the methylene linkage. Now when this enzyme is operating over, there is a formation of double bond in between. Here is the hydrogen is present, right? Oxygenase is supposed to induce the oxidation process, hydrogens to be removed. Whenever hydrogen removed, there is a double bond formation. Whenever double bond formed, it is becoming quaternary. Nitrogen is becoming quaternary, so that positive charge is induced over the nitrogen atom. Dehydroreticulum ion reductase. Now, required enzyme will be dehydroreticulinium ion reductase. This reductase enzyme able to release one of the hydrogen starting from NADPH into NADP positive. One of the hydrogen got released. Whenever hydrogen released over there, what it is going to do? It is able to condense. Cyclization carried in between. Here is the cyclization process taken between this carbon atom of benzene ring and nitrogen, whichever present over there, so that here you can observe this kind of bridgehead cyclization process. Whichever intermediate one more generated will be salutaridine. Salutaridine is another intermediate originated by this dehydroreticulinium ion reductase enzyme, where NADPH is transformed into NADP by releasing one of the hydrogen, so that here benzenoid nucleus turned into a quininoid one, and another intermediate got originated. The intermediate whichever generated is further gone through the enzymatic action. Once again, salutaridine reductase is the enzyme working upon, again, NADPH releases one of the hydrogen, giving NADP positive. And wherever ketonic functionality is there, that now again reduced into hydroxyl. That ketonic compound now shifted into the hydroxyl, that named as the salutaridinol, all indicated for hydroxyl functionality, and remaining skeleton unaffected. Then salutaridinol acyl transferase. Acyl transferase is a kind of another enzyme working on this intermediate. Once again, acetyl coenzyme A is releasing acetyl, and coenzyme A left over, and acetyl group released into the molecule. The acetyl group, whichever released, attacking on the hydroxyl, so O acylation taking place. O acylation is carried. The compound generated over here, the intermediate formed over here, will be salutaridinol 7-O acetate. It is named as a salutaridinol 7-O acetate as the intermediate. After that, we have to treat this intermediate with the mm, uh, spontaneous process. Spontaneously, it able to remove that. Being it is the bulky functionality, so immediate removal of this one is possible. And then there is the formation of Thebaine intermediate formation is possible. In order to achieve this one, let me give the suitable mechanism. The lone pair of electrons present in the oxygen taking part of the cyclization with this carbon atom. Whenever here the new bond formation between the oxygen and carbon, simultaneous shifting of this pi bond towards these two carbon atoms. Whenever pi bond is shifting over there, a simultaneous removal of this acetate moiety, we can say acetate moiety removal is possible. So here, ethereal linkage is originated in between these two, so that new cyclic ring is formed. And being this alkyl bridging is there from the top end. In order to avoid the steric obligation, this hydroxyl is coming from the back side, so that you can notice the dotted line bond with this benzene ring system. And here the ethereal linkage is originated as per the stereochemistry of this molecule, right? Whichever hydrogen positive and ACO minus, acetate minus, entirely discarded as a acetic acid molecule. This is the byproduct, and you observe this phenanthrene nucleus, and here the intermediate generated is called thebine. It is also the significant molecule in the synthesis of morphine. One more step we need to follow, that is demethylation. Demethylation stands for what? A methyl group to be removed. Here the methoxy is there. Methoxy will be shifted into the ketonic one. So enzyme to be operated in order to transform this methoxy into ketonic molecule, so that here demethylation got carried out. And here the neopenone is the kind of intermediate generated. Neopenone equilibrium is in the molecule. This neopenone is in equilibrium. Here is the double bond. Here is the ketonic one. This is some extent unstable because the conjugation is lacking over there. That's the reason why the double bond isomerization is also possible, which able to give the stable isomeric form alpha beta unsaturated ketonic compound, which is conjugated more stable in comparison to this neopenone. That's the reason why the intermediate whichever generated is called codenone. Codenone further converted into codyne. What difference you can notice? Ketone will be transformed into hydroxyl functionality. That is called a reduction process in the presence of codenone reductase enzyme. Codenone reductase enzyme able to transform this ketonic functionality into hydroxyl functionality, right? So this is the way codyne generated. Codyne, what to be formed, what to be changed from codyne to morphine? What change you are going to observe? Again, one more methoxy to be converted into hydroxyl. So in order to transform this methoxy into hydroxyl, demethylation process again carried out, so that both the edges are accompanied by the hydroxyl. This is about the morphine biosynthetic pathway. I'm going to start with this reticulin. So this is the reticulin, thebine, codyne are taken as the potential intermediate in the biosynthesis of this morphine. And it will be actually started with tyrosine. Tyrosine to morphine synthesis is possible. The entire schematic representation of the biosynthesis is given in this slide. Hopefully, the session is very informative and everybody enjoyed this information regarding the alkaloid, especially morphine. Morphine occurrence, significance, biosynthetic pathways in discussed in a extended manner. This is available at the channel World of Competitive Chemistry. Thank you, one and all.